This procedure aims for the iontophoretic application of pharmacological agents to microcircuits in the brain while simultaneously recording neural activity. First, pull a single-barrel glass electrode for single-cell recording and bend the tip. Also pull a multi-barrel glass electrode and break its tip to the desired diameter. Proceed to assemble the two electrodes. Ultimately, the produced electrode is used for extracellular in vivo recordings where, upon demand, pharmacological agents can be iontophoretically applied to manipulate neural microcircuits.
Hi, my name is Dr. Achim Klug, and our lab will show you today how to produce Piggy-Back Multibarrel Electrodes. These electrodes can be used to iontophoresis neural agonists and antagonists into the microenvironment of a neuron, and thus to manipulate neural circuits of a neuron in vivo.
Hello, I'm Dr. Anna Dondzillo. I'm postdoc in Dr. Achim Klug lab, and I will be demonstrating the procedure today.
For a single-barrel electrode, use a single-barrel glass capillary with filament and pull the tip to a diameter of about 1 to 2 micrometers, shaft length of 10 to 12 millimeters. Verify the resistance of the pulled electrodes sporadically by filling them with 3 molar sodium chloride and testing them with a standard ohm meter in 0.9% saline. Once the electrode is filled with salt solution, the solution dries out quickly, rendering the electrode useless. Therefore, only perform this testing step on some electrodes that will not be used for the piggyback production. To create a full multi-barrel electrode, pull the glass to a pipette tip of about 10 micrometers total diameter or less. An electrode with a correctly